obtained her PhD at the Max Planck Institute in Munich for astrophysics, where she was also awarded the Otto Hahn medal for her PhD. She's currently in Cambridge holding an ERC starting grant, and she has been able in a short while to build up a large group and do excellent work in the field of cosmology and galaxy formation and evolution. Unfortunately, she was not able to be here today because she's attending another conference, but she's prepared a video presentation for us.
Hello everybody, my name is EuroHPC and I would like to say that I'm extremely pleased and honored to having received Prace Ada Lovelace Award for HPC. And I would like to start this talk with a small tribute to Ada Lovelace herself, who achieved this gigantic mental leap from calculations to computation. And in her own words, the analytic engine may act upon other things besides number, where objects found whose mutual fundamental relations could be expressed by those of the abstract science of operations, and which should be also susceptible of adaptations to the action of the operating notation and mechanism of the engine. And I would argue that this quote very nicely encapsulates what we are still trying nowadays to achieve on high-performance computing, as well as the next generations of algorithms that we are writing for future architectures and platforms. So starting now with my own work, I want to tell you in this talk a little bit about our plans and ambitions towards exascale simulations of our own universe. So what are we trying to achieve here? Unlike the observational astronomers and astrophysicists who have telescopes in which they observe the sky, our telescope is actually high-performance computing facility, and our sky is the simulated sky, where we try to understand the fundamental laws of nature. So what are the big questions that we are trying to address with this approach? Really some of the most fundamental questions that you can think of in astrophysics. So how universe formed and evolved, why the universe on very large scales look as it does, how are the galaxies distributed throughout the universe, what are the galaxies made of, why do we have stars within the galaxies, how are stars born, how do they die, and also somewhat more exotic questions perhaps that are very pertinent to my own research, why there are supermassive black holes in our universe and which fundamental relationship do they have with the surroundings, stars, and also their host galaxies in which they are embedded in. So why are we trying to do simulations and what they are to answer these key questions? Well, it often occurs that the problem is way too complex to be solved with the traditional, we would say, analytical pen and paper approach. So we would have a certain equation like you might see on this slide here, which at the face value looks manageable, but often these sets of equations which actually describe the fundamental laws of physics that we want to apply to our universe are way too complex to be solved analytically, and they lead also not only to the complex but also nonlinear effects. And that's why we need supercomputers or high-performance computing facilities to be able to solve these sets of equations and to obtain as an end result something that we called a simulated galaxy or a simulated patch of the universe that we can then analyze in great detail. So how can we then simulate the whole universe? Well, to start with, our universe is actually rather strange. Even though in its infancy it starts rather with the simple initial conditions as we would told them, so almost uniform density and temperature field describe the very early universe very well. Soon it develops into very complex structure, And also the composition of the universe is rather strange. So most of the universe, as we know it today, is what we call dark. Why is that? Because most of the matter in the universe that reacts through gravity is dark, and that is what we call dark matter. Then there is a small component of the matter which is ordinary matter or baryons, and this is the component that we know relatively well. And then there is a large component which is called dark energy that drives actually the accelerated expansion of the universe itself. So how can we then simulate this all complex universe? Well, actually, to have a guess how the universe was in the very early times, we have some observations that are giving us really good and precise initial conditions. And then we can evolve the universe as a function of the cosmic time to a first approximation, assuming just that the gravity is the fundamental force that acts. And this is a depiction of this type of calculation. One of the larger simulations back then when it was executed, the Millennium simulation, where you can see the density field of the universe, which initially was rather smooth, but as the time progresses due to the gravity, the structures are bound and collapse together, and the universe becomes more and more clustered and more complex. And in this approximation, we neglect any contribution from baryons, that is gas or stars. So these so-called pure dark matter only simulations in our own cosmological model have made a remarkable actually progress over the last 40 years. So what I'm showing you here on the plot is the number of simulation particles versus the publication year of a paper that adopted this particular simulation. And you can see that the very first attempts in 1970, how they look like on the top. And you can see that nowadays we are entering the regime where we are simulating a patch of the universe with actually 8 trillion resolution elements or particles, as we call it. And one example of one of these such ambitious simulations is shown on the bottom, and you can see what is the extraordinary dynamic range and complexity of the universe and of the structure formation that we can capture with this simulation nowadays, which are obviously all performed on the HPC facilities. So unfortunately, that's not the end of the story. If you look at night, at the starry night, and if you're lucky enough to have a lovely view like this, what you see is actually not dark matter, which is dominating the total matter contribution of the universe, as I told you before, but it's actually gas and stars. And if we just estimate in our own galaxy, the Milky Way, we come to a number that there are more than 10 to the 68 hydrogen atoms in our own galaxy, and in the observable universe, probably there are around 10 to the 80 or more hydrogen atoms. So these numbers are really huge. So we have to somehow try to simulate this component that we clearly see on our observable skies, but that is extremely complex and that is represented by such a large number of individual particles. So obviously what we have to assume here is some discretization approximation to be able to reduce this number to something that we can simulate of order of 10 to the 10 or 10 to the 12 resolution elements. There is, however, another large complexity that is involved here, and this is not just due to the sheer numbers in resolution elements. There is also a vast range of spatial scales that we have to incorporate. So let me illustrate this in this slide here. So what we want to simulate when we think about the universe is actually a representative patch of the universe, which is fairly large. So we are talking of order of 10 to the 9 parsecs. But within this patch, we want to actually simulate individual galaxies themselves that have some characteristic size of order of 10 to the 3 parsecs. But to understand how the galaxies form in the very first place in this large patch of the universe, we have to actually simulate on the fly, self-consistently, also the components of the galaxies themselves. And this brings us again to an order of orders of magnitude smaller scales. Finally, we all know, also from this picture of the starry night, that galaxies are all made up of stars, and we want to understand how these stars form and evolve within individual galaxies and how actually do they build them up. So this brings us down again further to order of 0.1 parsecs in the case of the massive stars, or even to much smaller scales if we, for example, want to understand the winds from relatively massive stars. So that we have to understand the scales of order of 10 to the minus 8 to 10 to the minus 6 parsecs. And finally, there is a firm observational evidence that there are supermassive black holes in the cores of massive galaxies, but perhaps actually in the cores of majority of the galaxies in our universe. And if we want to understand the physics related with supermassive black holes in the cores of these galaxies, the scales become also much smaller. So we are talking of the scales below 10 to the minus 6 parsecs. So you can see that the dynamical range of scales is enormous here. And we ideally would like to simulate that all in one go. So this is currently computationally impossible to do, so we would have to we'll have to wait quite some time to be able to tackle more and more of important physical scales in our computations. But it's not just the single scales. A bunch of complex physical processes occur on these different scales. And given that these scales are mutually linked to each other and are talking to each other, and the physics depends, the physics on, let's say, on some smaller scales depends on the physics which is happening on smaller scales, we have this very complex nonlinear interplay of physics on mutual scales. And this makes this problem really computationally and physically challenging to solve in one go. So how are we trying to do this? Actually, we take our fundamental equations, which we think are governing the physical nature of the galaxies and the universe and the structures that form within, and we try to discretize this set of equations in different hydrodynamical codes that may be based on particles, so in a Lagrangian approach, may take a complex adaptive mesh reprinement meshes to be able to solve these sets of equations, or may take advantage of unstructured moving meshes. So there are different ways how we can solve these equations, and there are different advantages and disadvantages in these methods, trying to capture the physics exactly as possible. So I wanted to show you a really short movie illustrating this vast range of scales and the complexity of physics that we are trying to address in these types of simulations. So this movie here has been taken from the Illustrious simulation and is one of the largest simulations of galaxy formation that has been executed today. And you can see here the view of the universe at very early cosmic times, where you can see the formation of the very first objects, so the first stars, the first galaxies, and then as these objects form, the matter is condensed into these little knots, which are the galaxies, and they lie at the intersection of larger structures, which we call the cosmic web, or the filaments, large-scale filaments, through which the matter and the galaxies stream, and they accrete towards these knots, where larger and larger objects are created. And in this process also star formation is triggered, and also the accretion of the matter onto supermassive black hole happens, and then matter can be violently also expelled away from the center of the galaxies and actually into the intergalactic medium, the space between the galaxies, due to the action of the supernovae explosions or the very powerful explosions from creating supermassive black holes. So I wanted to tell you a little bit what is the current state of the art in this type of cosmological simulations that try to incorporate not just dark matter, but also the properties of gas and star formation and gas cooling and black hole accretion and all of these. So typically dynamical range is relatively large, but nothing compared to what we really would like to get on to in the future. So we are talking about perhaps a sub-kiloparsec scales to the scales of order of 100 megaparsecs. These simulations typically are running on 10,000 and more CPU times, so the codes are really very well parallelized. Typical simulation, a single simulation will take somewhere of order of 10 to 15 million CPU hours, and it generates of order of petabytes and petabytes of data that we have to then analyze to understand what is happening. And again, similarly to the previous types of calculations, so I'm showing you here the number of resolution elements as a function of the publication year, and you can see how much progress has been made in the field and where we stand. And some of these red points at the end of the diagram correspond to this illustrious simulation which I showed you just a second ago. So what are actually the main success stories of these simulations? So one of them is our finally ability to reproduce the galaxies as we see them in the observed universe. So here I'm showing you a result where on one side of the plot is the real observed universe with the Hubble Space Telescope, and on the other side it's our simulated or mock universe, and you can see that they really look alike. So this is one of the successes of this type of simulations, and I can show you another more kind of perhaps concrete example, and this is has been a long-standing problem in the field for 20 years or more. This is to reproduce the morphological diversity of galaxies. So there is something which is very well known in the field, which is called the Hubble tuning fork or the Hubble diagram, where the galaxies from when people first started observing them have been classified in some categories. And there are galaxies that look spherical, roundish, and they are called ellipticals, and there are galaxies that have a clear disk structure and perhaps the spiral arms or the bars in the center, and like our own Milky Way galaxy, and then there are galaxies with really irregular massive morphologies. And up to recently, this morphological diversity of galaxies, which is so well known in the observed galaxies, was not reproduced in any simulation results. So it was the illustrious and a couple of other simulations that came about in 2014 and onwards that were able for the first time to reproduce this morphological diversity of galaxies and actually to find the reason why this morphological diversity exists in the first place. And this comes from the presence actually of these supermassive black holes in the cores of the galaxies. So this is a little bit of a messy plot, so I won't enter into details, but we know that there is a correlation between the mass of the supermassive black hole that is sitting in the center of the galaxy against the stellar mass of its host galaxy. So the most massive the stellar mass of the galaxy, the more massive black hole is sitting at the center of the galaxy. And then you can start to see what is the morphology of the galaxy that is populating these different regions of the central diagram, and you find a very strong correlation for the galaxies that host the most massive black holes. Their morphologies transition from what we call the disk-dominated systems into the spheroidal elliptical galaxies. And we think the energy input from these supermassive black holes is actually the key ingredient that causes this morphological transformation. Okay, so let me now, in the last part of the talk, guide you to some more recent developments, where the field is moving and what we have been working on. So one is a new algorithmic development that, together with my former PhD student, Mike Curtis, I have been doing several years ago, and this is to try to zoom in into the central regions of the galaxies where these supermassive black holes reside, and to increase mass and spatial resolution there by many orders of magnitude to be able to capture the physical processes that happen in the central region much more accurately. Actually, if you remember this diagram of many different scales that happen, is to try to make a bridge between some of these scales. So I want to show you a small video how this looks like. So this is a simulated galaxy, and this mesh that you see on top, it's actually the computational domain, and you can see how that is resolved with individual cells. So now, as the time progresses, we are zooming in the center of the galaxies, but at the same time, the mesh is refining more and more in the central region to actually add this added dynamical resolution in mass and space. And you can see that also on the plots on the side. So in the top plot, you have the whole simulated galaxy, then you have to zoom in towards the central bar-like region, and then you have a zoom in all the way to the center, where you can see how many resolution elements we actually have added there. So what we can do with this approach of adding mass and spatial resolution, so one obvious application is that we can study jets. So these are collimated high velocity outflows which are launched from supermassive black holes, which are accreting, which we call active galactic nuclei. And I'm showing you an example where on the top you can see in the panels, in the two panels, you can see if you don't resolve the relevant scales, you actually cannot generate a jet, but only if you start resolving these very small scales, you can start essentially generating jet cell-consistently in these simulations. And on the bottom plot, you can see that these jets are now resolved with exquisite resolution in our simulations, and one can study many different properties of these jets, including the velocity field, the temperature, the density, vorticity, turbulence, and so on and so forth. So why is this important? When in essence we can now compare these jet simulations with real observations. And this is what we have recently done in a letter, where we have done a full cosmological simulation, simulating again a significant chunk of the universe and a very massive object that formed in the center of our simulated domain, which we call the galaxy cluster. And then in the central region of this galaxy cluster, we actually can zoom in. So there is this tiny yellow rectangle, which I guess you cannot even see. And if you zoom in there, then you can see the picture. Actually, what is happening there is the picture of the jet that is shown with these green colors. And this is this jet that has been launched, achieving this very high resolution in the central region. And then what we can study is actually in detail the properties of the jet. So we can zoom in even further, and you can see some of this in the bottom plots. And you can actually see the exquisite resolution with which we resolve the individual regions of the jet, and we can study the turbulence in the jet itself and the energy transport from the jet to the surrounding medium, which could be an important heating source of these objects, the galaxy clusters. So what we can do with these simulations, we can try to do images of our simulations that look something like observations, so we can try to process them in the same way, and that we call the mock observation. So in one panel again is the real observation of such a jet in an observed system, and the other one is our attempt to model this. So we are again with these new algorithmic developments coming close of resolving these jet structures with a great level of realism. So let me conclude this talk with a little bit outlook on the future. So obviously there is still a lot of work to be done, and high performance computing, if anything, its importance is going to increase in future. So our ultimate goal is to bridge the scales from really large scales of the universe down to the scales of galaxies, all the way down to the scales of accretion disks around supermassive black holes, and even the processes such as merging of supermassive black holes. And we want to do all of that in a single simulation, and this is where the field will be moving. So thank you very much for your attention.
So I've just been told that Deborah is actually traveling right now, so unfortunately she will not be able to connect for questions, but I think we should still, even though she's not present, well, thank her for this beautiful talk and congratulate her with the award. So the next session is the user forum open session. Yesterday we have seen in the parallel sessions many fantastic examples of all the exciting science that's being carried out with the Prace infrastructure. We also saw in the presentation of the scientific case for computing in Europe. And this session is dedicated to discussing Prace and HPC in Europe from the point of view of the users, because in one sense you can say they deliver the ultimate deliverable from Prace, all the exciting and excellent science and results, and also in some sense they're the main customers. So the first speaker of the session will tell us about the Prace application process and the peer review process. This is useful, I hope, for those of you who are already using Prace or thinking of using Prace in the future. And then in the second part of the session, we'll discuss and present a survey of by the users, tier 0 users of Prace, and the view of the Prace infrastructure and HPC. So first of all, it's a pleasure to welcome the first speaker of the session, Maria Grazia Giuffreda, who is working at the Swiss Supercomputing Center, but is really here today on behalf of Prace to present the application process and the peer review. So welcome.
So thank you very much for coming, and I hope that they are not the same people as last year, because my presentation will be very similar, but I've been asked to come again and to give you an overview of the peer review process and also the application, how to write a proposal that what are the information needed in the proposal such that you will be considered? So you all, this is the outline of my presentation. So I will give you, as I said, overview of the peer review process. Then I will underline what are the important the important part that you have to have in your proposals. And then I will show the template. Unfortunately, I believe that there are no members of the Access Committee participating this year. So, but there are the member of the Scientific Steering Committee. So hopefully, if you have questions that I will not be able to answer, we can either take it home and come back to you, or maybe Nuria can also help. So, we say these things many times, but it's always important to also repeat. So Prace is provided a federating European supercomputing infrastructure and is putting this infrastructure at service of the scientists all over Europe. This is a strict and strong, transparent peer review process and is purely based on scientific excellence. We all know that, you do a great job. We don't even have doubts on this, but these tier 0 calls are really a challenge for you. We would like you to come with scientific problems that you don't dare to do on your local system because you don't want to burn all your resources, but that you would still believe it's scientifically important enough to come to us and ask for a large allocation to do it. This is just practical information. So we have just closed call 19. Now the peer review process has started for the proposals that have been submitted. And the next call, you can also find this information, of course, on the Prace webpage, will be open on September 3rd, and then will be closed in the end of October. It is important, and I will say this many times during the talk today, I would really strongly advise you to come with a preparatory access to whatever center you decide, whatever machine you decide to apply, because there are a number of technical requirements asked now. We accept that you might not be fully into these technicalities to know how to collect all this data, and therefore it's important for you that you take advantage of the instruments that you have there. And these instruments are the preparatory access, so please come to us early enough so that we can help you collecting this data. And also this will make, I assume, your life easier, because you will mainly have to concentrate on the scientific part of your proposal. So the proposal can have a 1 year or multi-year duration. Your resource request must be for the first year anyway. And as it says, second and third year are not automatically granted. So you might be accepted for a multi-year project, but you will still have to come for presenting your data. You have to come to the Access Committee meeting and present your results, and the PI is expected to be there. Not a student, not a postdoc, but the PI, unless there are real reasons not to be there. Reason I say this, it's because this is really important for the Access Committee that PIs take this thing seriously. Who can apply? So whoever has an academic position and a researcher in an organization can apply into Prace. These information are all available on the web page, so I'm just quickly going through it. Okay, of course, the non-military is I smile when I see this, but maybe it has to be really also clear that this has to be purely scientific, open science. And if you are planning to submit the same proposal in different calls, even your national calls, you still have to declare, because double granting is really not permitted. These are currently the resources available in call 19, actually. I took it from the Prace webpage. So there are 2 new entries, and please, the asterisk means go on the web page and look for the details when these machines are available. But as I said, this is call 19, so it's done deal. You can't really do anything anymore. But there is the Joliot-Curie AMD machine coming into the pool, the AUK machine from HLRS, and then we still have the Jewels, Marconi at Cineca, Mare Nostrum at BSc, and then Pitzdine in Switzerland. So this is the pool of systems, a variety of systems that you have available in the Prace pool. So I want to stress that this this peer review process is not something that Prace has invented and has come up with it out of nothing. This is an ERC-like process. You all probably, or many of you, have applied also for ERC grants, and this is very similar. So you will have your proposal, once you submit your proposal, you will have an admin check. Then you will have rapporteur, that are member of the Access Committee, that will look at the proposal and assign scientific reviewers. Then the same proposal will be given to technical reviewers. And then the rapporteurs are grading your proposal based on this. I will go into detail, so this is why I'm a bit quick in this. Will grade your proposal, and then the Access Committee will come up with a recommendation of proposals, and then there will be the final step is the resource allocation panel that sits and start distributing the recommended proposal on the various machines. And the Prace Board of Directors has just to sign out the process. So this is the final step. So the administrative check, please, I would strongly advise you to take this seriously, because if mandatory data are missing, or you use the old template, or you, I don't know, you don't put your CVs, or your CV is 100 of pages, I don't know. But I mean, pay attention to this, because they do reject administratively. So if you don't comply with the requirements, you will be rejected administratively. And we know that's sad, because usually these are silly things that could have been easily avoided. So I would really recommend to you to take a moment to really go through the the submission process to make sure that everything is done as expected. So technical assessment. So the technical assessment is done by the centers, by the centers where you are applying for the machine that you are applying for. So you have to, as I said many times, or already several times, please try to come with a preparatory access. The call is open for 2 months, which is actually already the length of a preparatory access. So you could come to the center and ask for help if you need help. If you are fully independent, that's very good. But you can ask for help in collecting your data, such that then the technical review in the end will be a formality, because if you have already interacted with the center, you will be ready to go. The scientific assessment, the proposal is given to 3 scientific peer reviewers, and they will have to check the scientific merit of your proposal, the soundness of the methods that you are going to use, how appropriate is your timeline and the resources that you have asked for, whether the plan that you have provided is actually feasible, and then your expertise and your qualification. I mean, I guess this is standard. The Access Committee, as each proposal is actually assigned to 2 rapporteurs who are members of the Access Committee, and they have to suggest the peer reviewers, and then they also assess the reviews that come back. They have to actually advocate for the proposal or present the proposal in the Access meeting, and then they have also to suggest a final grade for the proposal. Of course, the scientific excellence is the criteria that will be used to accept or reject a proposal. Yeah, this I just said, the rapporteur will have to grade the proposal, and then the proposal are discussed in the Access Committee meeting. This is really, if you would sit in the Access Committee, like I also do, this is what you are going to see. So the rapporteur one will have to actually describe the proposal. Then is the technical teams are asked to give their feedback on the proposal. Now it's important, I think, to underline that proposals that they are technically rejected usually might not pass, even if they are scientifically good. Because the problem there is that we don't know if you will be able actually to run on the system. So if you do not pass the technical assessment, it means that there are data missing or the data are irrelevant for the machine that you were asking or for the code that you are using. So you have to understand that there is a combination of the various elements here. So you need to be as accurate as possible in your proposal. And then also the second rapporteur will be asked to discuss the proposal. And then there is an open discussion among the members of the Access Committee about each and every proposal. Yeah, and proposal, I mean, there are certain proposals, of course, that you might discuss more, and certain proposals that they are straightforward, and certain proposals that they are also straightforward in the rejection case. The final step is this resource allocation panel, where we sit to allocate or grant the proposals based on the recommendation of the Access Committee, the constraints on the Prace resources, and the administrative constraints and various agreements among the Prace partners. Usually this is a meeting that the managing director of Prace, Serge Bogaerts, is actually leading and taking care of. And so finally, considering all these constraints, the proposals are granted, and then the BOD confirms the allocation and sign off the process. The scientific assessment. So, the proposal, the scientific assessment wants to basically look at the merit, scientific merit of your proposal, and therefore you have to also, I mean, be enthusiastic about what you do and make sure that you demonstrate the interest of the science that you want to actually do. It's important because these are tier 0. I said in the very beginning, these are your chance to come up with very challenging problems, scientific problems that you want to address, and that probably the local resources will not be able to help you. And so you have to have some element of novelty and some element of novelty in your proposals. Relevance to the call. So the proposal has to describe the research that you're doing and has to comply with the tier 0 calls, I mean scope of the calls. These are described now extensively, so you shouldn't come up with something that is, that even if it's amazingly good, is not really HPC, because at the moment, I'm not saying that this will be forever, but at the moment the tier 0 calls are HPC calls. The methodology, so you have to describe the method that you want to use and show that these are appropriate to actually achieve your goal, your scientific goals. The dissemination, so it is important that you also have a plan on dissemination, and this is absolutely important that you come up with a list of publication, if this is not your first proposals, that you include in your proposal the list of publications that you have had out of Prace proposals where you actually acknowledge Prace. Please do acknowledge Prace if you have used resources via Prace, because otherwise these publication lists are not even considered and probably will be detrimental, because if this is not your first proposal and you have published without acknowledging that you have been given resources via Prace, this will be a minus rather than a plus. Because for Prace and also for our centers, I mean, your publications show that we are doing a good job and that we are actually granting resources to scientists that they are capable of producing interesting results. So it's not just to make your life miserable, as I say many times. It helps everybody. You have to have a solid management structure, and because they want to make sure that you will be able to succeed. The proposal template. Here I hope that I will not flood you with too many details, but just let's quickly go through this. This template was new, was new last year, so now it's not really new anymore. But you will be asked to provide a number of information. Now, what is very important is that the Access Committee understands that maybe for certain codes, for certain disciplines, not all the data can be provided. And this is absolutely okay as long as you explain this. So it's not that every single requirement is mandatory, but it is mandatory for you to give the information why, for your disciplines, for your codes, or whatever, things cannot be provided. That's all they are asking. So yes, the requirements are mandatory, but it is okay if you explain why you cannot provide this data. Yeah, okay, so and the other thing that it's also important is always keep in mind when you write these proposals that the Access Committee is composed of scientists from various disciplines. So you are writing a proposals that should be understood, not in all the details, I accept that, but should be understood also by scientists of different disciplines. Okay, once again, it's important if you can stress the impact the impact to society of your research, how HPC will help you to achieve what you are describing, and what are the major outcomes that you expect from your proposal. Yeah, okay. I apologize if some things are a bit of a repetition, because I have mentioned several of these things already. But maybe what is important is also that for industrial partners, they should also describe the potential economic and strategic business impact of their proposal. Because the industry can actually apply into the Prace calls. I think that the only real requirement is that the data have to be published in the end. So this cannot be secret science. Yeah, once again, describe the motivation, the state of the art of your proposal, and so on. So these are some of the requirements that I said you should provide if you can, but if you can't, that's acceptable as long as you actually explain why. One of things is the validation, so you should try to validate your model against experiments or other reference data that they are well established in your field. Same, verification. You should try to verify the numerical consistency of your method. Then they ask for the sensitivity analysis. I mean, if you can, you provide. If you can't, that's okay. But you should be really trying to describe it. I mean, to make them understand that you are aware of all these things. It's just that for whatever reason, you can't provide this data. it is important that you give an idea of what is the state of the art in your field and how your method or the things that you are going to do will actually have an impact. And then you have to have the technical description a bit more in detail. So you will have to tell us what are the codes that you want to use in your proposal, and you have to also justify and advocate for your choices. What are the libraries, whatever the tools that you need to be successful in running your proposal. And once again, this is also to make sure that where the machine where you are applying can provide the environment that you need to be successful. Same story, the programming, the parallel, okay, now this is, oops, sorry. Now this is kind of obvious. I mean, the whole application running on this machine are MPI, OpenMP, OpenACC, and so on. This is important, your I/O strategy, because sometimes if you don't come up also with the I/O description and strategy, this might be a bottleneck in the end, and you will not be able to do what you plan to do, just because you are not describing and you are not going on the machine and actually test your workflow. Indeed, so you need to think about your project workflow and about the pre and post processing, about the production of the data. I mean, this conference, everybody is talking about the data. So you need to make sure that you are asking for what you need, because not always the center can then improvise and all of a sudden give you a petabyte of storage date. I mean, so you have to think that it is important that you really think about what you need to be successful. The performance, the benchmarking of your software. Here there is, I think, another kind of misunderstanding. When we ask you to come with your scalable, your benchmarks and for your codes, is not because we don't believe that the codes can actually run on this machine and can even scale on this machine. But we are asking you to benchmark a representative case for your proposal such that you can also, based on that, come up with the proper justification of resources. So come up with the resources that you actually need to be successful. So these are not random information that have been that are asked. These are information to make sure that we give you what you need to be successful. Yeah, and this is, in other words, what I just said. These are some of the other things that that you will be asked, and I am basically at the end of the presentation, so I'm not going to go through all these details. But once again, my strong recommendation for you is think what are the machine that you want to apply for, contact the center, or come even better, come with a preparatory access and ask for help from the technical teams. Because we are there to help you to make sure that the technical description of your proposal is not a big headache, but so we will help you to put this together. Of course, for the scientific part, that's a different story, because there you are on your own. You will have to take care of everything. But for the technical part, we can certainly help you. And Prace as an infrastructure there that can certainly help you put together the technical part. So, okay, and this is the very final part. It is also important that in your project, you clearly also described your team, because I have seen that for the Access Committee is relevant to know also who are the people that they are going to work with you. And I think it's also due to the people that they will work to you. And what are your various, strategies? And also remember, once again, that when you publish papers that have come out from Prace allocations, to acknowledge Prace and the center that has given you the resources. All I have told you now today is available on the Prace web pages. So I give some links. I don't know if the presentation will be made available probably on the web page. So these documents are, of course, for call 19. We have just closed call 19. And then, but information on deadlines are already there. And with this, I hope I haven't bored you too much. And I thank you for your attention. Do you want me to sit here? Or?
Yeah, let's take questions first. Yes. Thank you, Maria. Questions? So everything is, yeah?
Hello. What about the continuation, applications for continuation of current projects?
Oriol, you are in the, this is, maybe you answer better to this one. Or you come here. Yeah.
So this is Oriol Pineda, a colleague of Maria Grazia in the board of directors of Prace. So I don't know who asked, but you asked about, over there, good, just to look at you. So you asked about continuation of existing projects. This is a way, it's kind of multi-year, but it allows you to ask as many resources as you need. So as you know, multi-years have this limitation of maximum 10% of the resources of the system, while in the case of continuation, there is no limitation. The other part is that you compete with the rest of the proposals. So this is the main difference, but it's in case you really need a strong fraction of resources, then you need to do a full application. Then this includes a progress report. Yeah. So you show to the scientific reviewers, to the technical reviewers, and to the Access Committee, which has been the progress in your first or in your previous year, and then they take everything into account.
Yeah, and of course your proposal cannot be simply cut and paste of the previous one. You will have to clearly say what are the new milestones and goals that you plan to achieve, or for whatever reason, if you haven't achieved your previous one, what were the reasons not to and why you will need a continuation. And I think you have to clearly say that this is a continuation of a proposal.
Yes, I mean, you have the option to say this is continuation, and it's good and bad for you. So you will be evaluated for the novelty and for what you have done. So if you didn't achieve your results, it's not good for you. Is it clear? Okay,
yeah,
later we can continue.
Yeah.
Okay, other questions? Yes?
There is one here, I don't know. Yes, I have a question here in the bottom.
Yeah.
Very nice. As for acknowledgement in publications, do you have a tool to extract these acknowledgements and the publications from the web, or do we have to send something to a repository, or how is officially found what is acknowledging and what not? I mean,
We check.
you check by yourself.
Yeah, we check that at the time of submission, because you are in the template, we ask you to report the list of publications from Prace proposals, from previous Prace proposals. So if you list a number of publications there, we check whether you acknowledge Prace or not. Yeah, if you mean, do we do it in a more automatic way? Not yet, not yet. We are working on it, but not yet.
So what we do is you can use all these search engines, so like ResearchGate or others, and there we extract the statistics, but not per person. So we know that 2018, we got acknowledged like 120 times. So that we can do as well.
There is a first, please.
Question about the multi-year projects. You said that the PI has to be present for
Yes.
the defense.
Yes.
However, assume that she or he is sick and in hospital or
As
on parental leave. What is done then?
Let's be reasonable. I said that the PI is expected to be present and to present the results. Of course, if this is not possible for whatever reason, no, that's not the correct statement. If there are serious reason why the PI cannot come, of course, it goes without saying that you can send your postdoc or the other person, your co-PI or the other person that is actually helping you in the proposal. But there must be a reason for this. It cannot simply be because you prefer the conference in the US rather than the renewal of your proposal. Unless, of course, we inform you too late, that's acceptable. Because if we tell you too late and you have already been asked to give a talk in the whatever other conference, but you have to properly inform the access committee of the reason why, in this case the peer review office, why you will not be able to attend. That's what it is. It's not that we are unreasonable or crazy people.
Okay, so we have a question in the back.
It's not a question per se, but since this is a users forum, at least, well, I'll try to get you some feedback from a user. I've had several of the Prace allocations. So on the one hand, it's a wonderful tool, for sure. But recently also there's a clear trend that I think is largely believed to be, there's a clear trend in the increase of the technicalities, a trend in the increase of basically what is asked for. Now the proposal is something like 20 pages. Some years back it was much shorter than that. The multi-year goes in the right direction, but it is actually extremely difficult to actually get into the second and third year, even though you could be allocated a multi-year project. So in that sense, you write a bigger proposal for the multi-year, and then the next year you're in the position to redo one single year application. There are plenty of things like that that look more like, you know, entropy increase than actual, you know, user-friendly approaches.
Yeah, but I think it's important that there is a limit to the user-friendly in the sense that you are asking for core hours, node hours, and so for you maybe it's not clear. Maybe the more important, the best thing would be if you ask for money, because these are money that you are asking for. So I do understand that we ask you to really make an effort to write these proposals. And it's clear, there's no discussion there. This is a serious effort and you need time to prepare these proposals. But we also are aware that we have increased the technical data that we ask you to provide. And this is why today I said over and over and over to please come to us. I mean, I guess you have an idea which machine you are applying for. So to come to us well in advance so that we can actually help you to collect this data, so that for you this is not a headache, but it's just a few days intensive work maybe with us, but then it's done. And then you can concentrate on the scientific part. But these are tier 0 proposals. So you are coming with challenging problems. You are asking, hopefully, for large allocations. So you have to be a bit aware of what you are doing and how you are doing it on these systems. Okay. I know this is not the answer that you would like to hear, but...
I agree, but if I just, short follow-up, for instance, last year I was awarded a multi-year project. I was exactly in the situation where I had to be in the US at the same time and not be in Brussels to actually defend the second and third year. So that went on really badly because I sent a collaborator of mine, even though the Prace committee was well aware of it. He was given a rough time because I was not present in person. We were not allocated the second and third year on the basis that, for instance, there is no publications yet. But this is unreasonable because you cannot have a published paper for a challenging problem in 11 months' time, for instance. So it's all of those directions which actually, on the one hand, it's a wonderful tool, and on the other, I think this is not really user-driven, in some respects.
Yeah.
So maybe if I can add, the objective of Prace is to go beyond national capabilities. So the idea is whatever you cannot do on national, you come to Prace. So this is also the high minimum requests. So we understand our requirements are quite strong. We work on making them somehow user-friendly, and certainly the multi-year is a way where we can improve. But the thing is that we are really going for the Champions League, or even beyond that. So we are beyond national and on the top of European, so it's not easy. So we were in fact in the Access Committee where your multi-year was reviewed, and maybe we can learn something about it as well.
Okay, thank you. There's last question there.
Thank you. I have a question about possible consistency or inconsistency between the Access Committee assessment and assessment from another committee. For example, let's suppose I've been granted a project under H2020 after a thorough assessment of my proposal, and then in that proposal there is a need for large-scale simulations. Then I apply for a grant from the Prace, and I get another assessment from the Access Committee. Could it be inconsistencies between the two assessments? That is, could the Prace, the Access Committee deny my project? So that would imply that I cannot fulfill my project, which was positively assessed in the H2020, for example, review process. Is that possible in principle?
But is this something that happened to you, or it's an hypothetical scenario?
No, it's an hypothesis.
Okay, it's an hypothetical scenario.
To me, it could happen because when you have different review processes, they may end up with different opinions.
Yeah, of course, that's always the case.
People are not the same, and they can have different
But also
ideas.
because the focuses are different. Because this access committee, of course, is the scientific merit joined with the technical part, because you are asking for large allocation on specific machines. I see we do have these kind of scenarios because we have funding agencies that they are funding scientific proposals, and then they apply for resources at the centers. So this is not an uncommon situation. But then either we have a unified access committee that takes care of both, or we need to find a different. But I don't have an answer to you. How do we solve this problem? But this is a possible scenario.
Okay,
Oriol,
thank you.
I don't know if you have
on this topic, maybe the question is how dependent are the two applications? So meaning you got one application for one project that probably is relevant per se, and then you ask for resources. If these resources are completely necessary, then maybe they shouldn't give the application at the start, because this is a conditional. So in this line, we have one example where we fully trust the Commission review. This is for the Centers of Excellence, and they have a dedicated access. And we expect that with EuroHPC, that they have, we have here the high representatives, maybe we can have joint calls for both money and cycles to really give them together. because if the project is meaningless without the resources, then the cycles are meaningless without the project. So we need really, like you said, a common thing. So far, this is only happening with the Center of Excellence, but it's really a new access mechanism for the future to explore with EuroHPC.
Okay, thank you. So we already have a good discussion going on the different aspects of access and uses. So this is a good time to continue with the second part of the session where Turlock Downs will present the Prace User Forum and also to expand this discussion beyond this room. We have been carrying out a survey by present and past Tier 0 users to know what is their opinion and thoughts about Prace and the HPC landscape.
Thanks, Trolls. Okay, so for those of you who've been at PRACEdays things before, the first few slides are things you'll have seen before. I just want to kind of remind everybody what the Prace User Forum is and who we are. And at the moment, at this meeting, there are three of us. So there's me, there's Trolls, and there's Teresa, who are all members of the program committee of the User Forum. So the role of the User Forum is really to try to be a kind of some kind of formalized communication channel between the user community, so Prace users and Prace itself, and the resource providers. We have a program committee, like I mentioned, and we organize things like the User Forum here today. And we also try to identify common user problems. So, I mean, individual problems from an individual user, if nobody else has those problems, that's probably not something we're going to pursue terribly enthusiastically. But if there's a problem that is coming up continually for groups of users, then that is something that we can try to talk to Prace about. So in terms of who is in the user forum, well, anybody who's been a Prace user in the past 5 years is considered to be a member of the user forum. Okay, so that's how you get in. And then the program committee, we are all members of the user forum. So this, I don't expect everybody to. Oh, sorry. I don't expect everybody to read all this, but this is who the program committee currently is. So we have a fair scattering in terms of the disciplines represented, and also in terms of geography. So a lot of different countries are represented as well, and that's done deliberately in order to be sure that we have the relevant expertise on the program committee. Okay, so what I'm going to do before handing back to Trolls is to just present the first part of a survey that was carried out by the user forum of Prace users. Okay, so this is Prace users. This is not an attempt to survey all possible HPC users in Europe. It's just of the Prace users, and therefore there's going to be a bias in some of the responses as a result. But we wanted to find out really, just as a means of accessing what might be the kinds of problems that people are encountering, we asked people a few questions. Okay, so this was sent out to all Prace users and or Prace PIs, and then people filled it in. Okay, so we got 50 responses from a large variety of disciplines. So it's pretty representative. Remember that the 50 responses are from Prace PIs. It's not individual users as such. So it's basically 50 research groups. And the first question that I'm going to try to look at here before handing back to Trolls is to try to figure out what is a typical HPC user, Tier 0 HPC user, specifically Prace Tier 0 HPC user. So in terms of whether, who they are or what kind of organization they work for, you can see basically almost everybody's an academic. There are research organizations. We didn't get any responses from industry users, but I suppose in some sense if there are 50 PIs responding, then you work out what fraction of a person should be responding for industry given the number of industry awards that occur. So it's not too surprising that we got 0 responses from industry maybe. In terms of the disciplines, you can see that there's a good scattering. A lot of physics, I suppose, maybe a little maybe chemistry and materials and engineering are a little underrepresented in terms of the responses that we got. when compared to the core hours that are used. But at the same time, we could expect that the responses that we get will give us a fairly reasonable picture of what tier 0 users are. Okay, so in terms of, one of the questions was basically how many CPU hours does your group use per year? And you can see that the largest group there uses between 10 million and 100 million core CPU hours per year. And then we have some who use more than 100 million core hours, and that's just that, purple one here, which is 12%, which is a reasonable amount, and then some in the smaller range. Again, you would expect that if you're talking to Prace users or Prace PIs, then their groups should be using lots of CPU hours. That's what you would expect. But still, 10 to 100 million CPU hours a year in the group is what you would expect people to be using. Now, the type of code, I think this is kind of relevant for the way that HPC is being developed in Europe. From a policy perspective, the type of codes that are being run. So the top bar here, so these figures all add up to more than 100% because you could check more than one box if you used more than one type of code. So 38% of the responses used in-house developed codes. And then another 58% used in-house developed codes that are heavily optimized. Okay, so you can add those two figures together. And you find that an awful lot of the tier 0 users use in-house developed codes, not community codes. And this is maybe something that people might find concerning in some respects, because in-house sometimes means there are errors in the code that nobody talks about and so on and so forth. But really that is part of the strength of European HPC, is that there is this wide diversity of codes, so you can get validation of research results by people running essentially the same problem but using different algorithms. So this is a good thing, I would have said, and the user forum certainly views this as a good thing, that there are a lot of in-house developed codes being used. Then we have the standard packages. People who use standard packages, a small number of groups use standard packages. And then we have a decent number who use standard packages for your field. So these are quite domain-specific packages, so I guess these would be the community codes. So there's a reasonable number of people who do use community codes, and there are a lot of people who use in-house codes. So a lot of the core hours that are currently being consumed on tier 0 systems in Europe are in-house, and then the next biggest group is community codes. So you can see that this is just basically summarizing what I said there already. Then the architecture that's used, so it's always difficult, of course, as new types of architecture come on stream. It depends on the size of the group and the resources that you have access to, as to whether you're going to be able to make use of those architectures. So still, perhaps unsurprisingly, the majority are happy at least to use multi-core processors. And then we do have a growing number who are capable of, who have ported their codes essentially to many cores, so that's kind of GPUs or KNLs. And then on the bottom here is just the Prace machines that were used. So these are from the responses, so you can see that we have a large spread of Prace machines. We didn't just get users who use one particular machine responding. Okay, so multi-core is unsurprisingly still the most popular for people who are using Prace. But again, maybe that's not too surprising. And there's a growing adoption of the newer technologies. Okay, so just to summarize before I hand back to Truls, your typical tier 0 user in the sense of being a Prace user is academic and uses 10 to 100, is in a group that uses 10 to 100 million CPU hours per year, and typically uses an in-house code, and then likes to use multi-core, but growing adoption of more modern technologies. So I think I suppose in one sense the surprising thing here, to me at least, is that there are so many people who are using in-house codes. So much of European HPC relies on in-house codes at the moment at least. So I'll hand over to Truls now.
So the next question that we wanted to ask is what is the view of users of the Prace application process? This is important because if the process is too burdensome, then maybe there are less people applying, and if it's too easy in some sense, then maybe there's not a good enough job of filtering out who are really the most suited people who can deliver the best science. So if we ask people, how does it compare to other grants of similar value? And as you can see, it seems to be well balanced. So people find that looking at the value that it represents, there's the amount of effort going into the application is fair. And then looking at the different parts, what about the technical justification? It is as expected. There's a little bit, people find it a little bit hard to gather the data. As Maria just told you, this is something that at one hand has become more difficult for the last call, but on the other hand it's also being stressed that there's a lot of support available to gather this data. And these are just some of the quotes that we got from people. More specific guidelines, I think we just got them in the last part of the session. And also some questions about how to actually carry out the scalability. When it comes to the science, it's actually pretty straightforward, not surprisingly. Scientists like to talk about their science, so they're all happy about that. We know how to write articles and know how to respond to referee comments, and this is also something that at least we've heard also informally from many people, that everybody very happy about this system where you get the possibility of responding to the referee comments and actually give a balanced response to the criticism. When it comes to the praise calls, there's also this question, does it really match the type of science that people are carrying out? What would be the optimal frequency and size? And as you can see, again, there's probably some bias because the people who are applying and getting the calls are also the ones that maybe have projects that fits well with it. But the most the one that's most suited for people is actually the standard 2 calls per year for one large allocation. Some people would like to see smaller allocations. I think those should maybe go to the national systems. And then you see that there is a number of PIs that are interested in these 3 allocations. This was also what we heard before during the questions. And another thing that's maybe interesting is that a lot of people would like to see the possibility of just checking off, okay, I need to run on a GPU system, or I need to run on a multi-core system with InfiniBand, and then it doesn't really matter where you're scheduled. Yeah, and then there's some questions about the timescales. So this is just one comment. We got difficult timescales, but I think this is really a balance between doing a thorough job of the evaluation and then getting the whole application through the evaluation pipeline. When it comes to the infrastructure and experience, we were interested in hearing what is the view of the people who are actually using it, of how well is the workflow supported, how well are they supported by the infrastructure available from Prace. And as you can see that overall people are really happy about the workflow, so it matches well what people are actually executing. And this is also reflected when we ask what is the type of workflow that you're doing. But again, there's a bias here because the Prace machines are strongly geared towards large-scale capability modeling. While we see some uptake, and this has also been discussed, I think, during this meeting, of people wanting to do large-scale embarrassing parallel simulations, large-scale post-processing, so more data-oriented science, really processing the data. So this is maybe something to consider. And there's actually also a pretty strong request for long-term storage, which I think is beginning to be addressed also by Prace. When it comes to how easy to start up, it's a mixed bag. While when we look at how are the reporting requirements, again, doing this comparison with other grants of similar value, it seems that Prace is hitting the nail, and it's perceived as fair. So there's reasonable requirements. So overall, bottom line, would you apply to Prace again? And I think this is a success story. Yes, definitely. When we go into the comments, then it becomes very clear why Prace and also EuroHPC and future pan-European HPC infrastructures are so important, because they're really giving a unique infrastructure for people in Europe to carry forward their science and be at the, say, at the forefront in the fields. So these are just some of the comments. I think in Europe there's no other alternative than Prace if one needs allocation of size of over 100 million core hours. Great opportunity to make progress in my research. I really appreciate the 3 years projects. Research grants by Prace are necessary for the completion of our work. There are also a few other cautionary remarks, but they're actually pretty minor in compared. So some people are complaining about the technical remarks. I think we already had a discussion about that. And also some would like to see smaller grants. Now, another thing we wanted to know is Prace still relevant? Or is it superseded by other facilities? And that was also pretty uniform. It was no. Prace is very important. It's not superseded by other facilities, while a few people feel that they have the sufficient support for their applications in national centers. Maybe that is mostly the case for groups coming from large countries that already have tier 0-like infrastructure. So finally, so the bottom line here is that Prace is an indispensable infrastructure to do the science, and it cannot really be done with national resources. We also asked the users, do you have some comments to Prace that you want to express? And there was a lot of small practical things, but we just wanted to pick out 2 that we think are relevant, namely that the 3-year access is crucial for sustained long-term ambitious science projects. This is also what I'm hearing before in the discussion. And also the suggestion, which I think is quite relevant in the debate of today, suggestion for the HLSTs, look for collaborations with high-level support team experts that result in new algorithms or implementations advancing the field. And one could add, taking into account what Turlock already discussed about the in-house codes and the diversity of the applications in Europe, maintain European excellence in applications. So what have we learned? You could say it's a little bit boring result, in the sense that people are not complaining so much. It seems that Prace has set up a fantastic mechanism for grading and selecting applications, and also a really unique infrastructure for European researchers. It's a resounding success, I would say. But also I think one interesting thing is the typical tier 0 user is somebody who comes from a group who uses 10 to 100 million CPU hours, use in-house developed code. So these are medium-sized research groups with a large variety of codes. So that's an important lesson, especially looking ahead. Application diversity is an important characteristic. So what does that tell you? Well, it tells you that it's really important to prepare enough users to run on the pre-exascale systems. And that requires diversity. And maybe one thing to keep in mind when we look at the landscape of community codes is that most of these community codes actually grew organically starting out as an in-house code. So it's important to have this growth layer, both because these small focused teams will be the ones who will be the first ones to run on the pre-exascale systems, but also because those are maybe the ones that will, deliver the new, GROMAX for the next decade. And one suggestion that we just want to to put up, maybe to open the discussion, is that it's really important because systems are so complicated to have, for example, the general libraries developed by the COEs to have support for large community codes, because these are very important in some fields of research in Europe, but it's also important to have some mechanism in place that can support the continued development of the in-house codes. And there are many ways of doing that, but one way that would not fragment, say, the resources is to use the established mechanism of the high-level support teams to support development of in-house codes, algorithmic long-term development, but at the same time maintain the expertise at the hosting centers. So thank you for listening, and now we'll take questions and open the discussion.
First of all, just a congratulations to the user forum for the organization of this survey. This is a really brilliant work, and as Prace Managing Director, I'm very happy to hear the message that the infrastructure has done a very good job. I'm just a little bit puzzled with this very positive outcome of the survey, and also the trend that we have been observing of a relative decrease of the number of proposals submitted to the Prace calls. So this is a bit a contradicting result, I would tend to say. So would it be, I mean, with my scientific background, would it be that some of our hypotheses were wrongly set in doing this experiment and that we are missing a part of the reality there? I'm not too sure, so I would be happy to hear you on that. Especially in the terms of, I'm trying to figure out whether the message of the applicants and the Prace users is, we definitely need this, but they did not really feedback on how much resources they were applying for outside of the scope of the European framework. Maybe this is something that they did not reflect in answering, maybe, or you see what I mean? If in the total amount of resources they are using per year, how much do they use in the Prace resources, how much did they use in the national resource, how much did they use in the international resource? That would have, I guess this is not part of your survey.
Well, we did actually ask, we didn't put that up on the slides, but we did ask them, what other resources do you access? We did not ask the question, how big a fraction of your resources are from Prace. But what we did see there, which is maybe worth reflecting, is that, of course, the dominant other source are the DECI Tier 1, national Tier 1 resources, but also there's a large fraction, I think it was 15 out of 50 respondents that use large-scale facilities in the US, as some people use facilities in Asia. As Turlock also said in the beginning, there is some bias when you carry out surveys, because sometimes you only get responses from the ones, well, you only get responses from the ones that want to respond, right? And they may be the active users. So one question is maybe what fraction of possible users of Tier 0 systems are not doing this because they perceive the burden of the application to be too large? And what can be done to enable their application, right? Because of course one wants to have a reasonable oversubscription factor, so you get really the best science done.
Thanks again.
Other questions?
So you were showing a 60-40% split between the in-house and community codes. I don't know if you did the exercise of weighting the answers by the number of core hours, and if you would see the same split.
No, we didn't. And it also, you need to be a little bit careful because the people answering that question could check a number of boxes. So it's not straightforward to interpret those results to say that there was a 60-40 split. I'm not aware of the core hours used by in-house codes versus the core hours used by community codes. Ah, yes, sorry, I'd forgotten that. Yeah, it is true that the 15 largest groups or largest users all use in-house codes. So of the respondents, of the 50 respondents, the 15 largest all use in-house codes.
Thank you.
Yeah, thank you very much for the work. And I think just to ask for an addition, it would be useful to get a picture of the most used codes in terms of what codes, especially the ones that are community or shared codes. But that's something that could help if you have it to make it available. I have another point that relates to the transition towards the pre-exascale or even exascale machines. For that purpose, I think all codes, even the in-house ones, but also the major ones, would need to use the resources for development which have to be in the large machines. And this access to that, I don't think it would fit with the current selection process of Prace. I mean, you would, if you ask for a project, you are valued on the merit of the scientific outcome, essentially, and it's not always the case that this coincides with the effort that, I mean, two projects that would have a high scientific merit and limited development, and another one where you have strong effort on development and an intermediate phase where the scientific merit is not yet up to the level. I think the first one would get a Prace project for sure, the second one not. So how do we deal with this? I think we really need, it's really the very definition of excellence in the Prace calls that would not enable us to get proposal through that will then lead to a good evolution of codes and bring us towards the pre-exascale and exascale success in code. So I hope.
I can take this in the sense that in Prace we are thinking and we are actually considering to have a so-called development project allocation. Because, well, it depends what we are talking here also. So if you think about development, but you still will need large allocations, this will still need to be peer-reviewed. But if you think in terms of development, because you need to have access to several machines, but with very reasonable or small allocations, this is what we are trying to actually put in place, to offer a development access that will not necessarily, will not for sure have this peer review extensive process.
That's certainly useful, I think, but there's also heavy computation needed in order to test, to push the development on the longer term and more ambitious targets. So I think in that case, I think it's fair to have peer review, but I don't mind selection and checking, but you have to have a criterion that is based on a different target, which is not purely the science publications and all that.
Absolutely. For a development, large development, let's call it like that, I fully agree.
Then it could be that some of the, since the COEs, for example, are working in that direction, maybe you would accept that some of the COE background is already an element for you to know whether this is going in the direction. I don't know if there's a way of simplifying that type of selection, but for sure we do need it.
Thank you. This is important feedback.
Just want to come back on that point. I don't think we can rely on the COEs because I mean they're very focused on a certain small number of codes. They're very important codes, but you know, to maintain a good European ecosystem of HPC codes, we can't just rely on the COEs to carry that out. So we need some other mechanism as well.
I would like to ask you about the whether you investigated the preparatory access Type C, for example. How many of such proposals has been rejected due to, for example, a lack of the Prace expert? Because this is I have seen the situations that it was a bit of a problem. So group didn't get the C, but they could do B, and do the development without the Prace expert. And have you investigated what was the percentage of the Type B development or Type C?
I don't know if Oriol again can answer this question, because as far to my knowledge there was no statistics collected, but maybe Oriol you know better.
But I'm just saying that you should I think to get knowledge about the new users, you probably should get information about that, because these people which are developing the codes and could have problems with accessing to experts of Prace could be your potential new users, yeah?
Certainly. So I don't have exact statistics, so I will give you tentative numbers that I have on my head. And certainly preparatory access is a mechanism to get new codes, new users, new people to jump in. So for Type C, I think it's maybe 10-15% are rejected because of lack of the appropriate support. What's important in these cases is that maybe the applicants can also point us to certain people because we have limitation of experts and also sometimes in the capacity to provide the effort. So we may have the experts, but for that year there's no more capacity. But it's a tentative number. I would say 10-15% are rejected. It's not very bad. Then another interesting analysis that we need to do is how many Type Bs turn into new proposals. So we know most Type As go into proposals, certainly, because that's only for benchmarking. For Type Bs, we need to do the analysis, which is an important one, and also see maybe not the ones that go, but the ones that don't go. What happened there?
Definitely.
Thank you.
You concluded with the interesting proposal to more tightly connect the people developing the codes and the supercomputing people through the HLST. So one community that seems to be doing that quite well is, for instance, in chemistry, it seems, but there they have a large community of users. In the HPC centers, you have dedicated people that actually know specific codes and are thus extremely good to actually interact with the developers. But as you mentioned through this survey, the typical Prace user is a medium or small-sized kind of research unit. You don't have that large community of users. So how could you enact this very interesting idea to bridge more tightly people in the HPC and people actually developing the code and close to the applications?
Well, what we believe is that there's a lot of value in all these groups that have, say, smaller codes. I think some of the people taking off in-house codes, that's maybe a code used by a number of groups with 50 or up to 100 users. So there's still a value in developing those codes. It could also be codes that are used by much fewer people, but actually are doing, say, the frontline science and using really a lot of core hours. So even if there are few people using them, it has a lot of scientific value. And those would be also probably some of the first ones, because they have the technical insight, some of the first ones to run on the pre-exascale systems. Now, this kind of communities that are maybe up to 100 users, they are too small to fit for the application of a COE or of a FedHPC project. But on the other hand, they're really important to maintain this diversity and lead that we have in applications in Europe. And what we're saying is that maybe the high-level support teams can produce, can be a centralized resource, but with the right, say, level of commitment that it makes sense to support these codes. That is a suggestion, because we think it's important to carry everybody into the pre-exascale era. So the view is, yes, of course, small groups cannot access these very large grants, but there has to be some other mechanism where you maybe have a fraction of an FTE during a number of years to do the algorithmic development, or other several things that will make it ready to run on the next generation of systems.
So just, I mean, one could imagine, it's always dangerous to give an example of what you could do because everybody shoots it down, but still one could imagine a scenario where there would be a call and you would apply under that call for access to HLST resource, and then the HLSTs would dedicate whatever you said you needed if you're successful in your proposal, perhaps an FTE for a year or an FTE for 2 years if it's a huge thing, but you could imagine it kind of a competitive program of calls of that nature, which would help to maintain a kind of large-scale diversity of the codes without needing to, you know, disperse your expertise all over the place.
My comment is that I would like to mention the existence of, within the COEs which have specific domains of expertise, but there's also, in our case, the POP Center of Excellence, where we do provide support and assessments and guidance to people about doing some of these adaptations or refactorings of the codes. And I see this as very complementary to the Prace support staff, and probably we should try to push even a little bit more the cooperation in this direction.
Yes, certainly, I agree with that. And I think since we are the only ones standing between you and lunch, I would thank all of you for the many good suggestions and questions, and also my colleagues here. So thank you, everybody, and let's have lunch.